Okay, so this video is going to go over pages 1 through 4. So statistics is a study of how to collect, organize, analyze, and interpret numerical information from data. It all begins by posing a question. A question about something, some people, somewhere. After you pose your question, you're going to want to design an experiment. Whether it's a survey or something like that. Then from your experiment, you're going to collect data. You got to decide how you're going to do that. From there, you're going to organize that data, probably in some sort of spreadsheet. Then you would analyze that data, still in that spreadsheet, perform calculations and whatnot. Using those calculations, you would then interpret what they mean, P-R-E-T. And then once you organize, analyze, interpret, you're going to communicate those results. And usually that's done with some sort of graph or visual to communicate those interpreted pieces of data. And this is kind of the system you would use to kind of go through a statistical analysis of something. So these questions I'll let you answer on your own. Maybe that's something we'll discuss. If you go to then page 2, and right up here, individuals are the people or objects included in the study. A variable is a characteristic of the individual to be measured or observed. So for example, individuals in a study might be the people who climbed Mount Everest. Those would be the individuals. Now the variable that we could study could be any number of things. It could be their age, it could be their gender, things like that would be the variable we could study from those individuals. Next, we would have, there are a couple different types of variables. We have quantitative. So a quantitative variable has a value or numerical measurement for which operations such as addition or averaging make sense. So let's use the Mount Everest example. This could be maybe a quantitative, their weight. Weight of Mount Everest climbers. Quantitative, because it's an actual number that we could add and average if we wanted to. Still on page 2, a qualitative variable, that's a V, sorry, describes an individual by placing the individual into a category or group such as male or female. So for example, why don't we just use that for our example, the gender of Mount Everest climbers would be a qualitative variable because it's describing those people as either male or female. So a couple more vocabulary words. A population is all of the individuals of interest. Now this doesn't always mean everyone. If you're talking about, you want to find out, let's say, favorite ice cream flavors of Batavia High students, well then our population would be students at Batavia High. If we're talking about what's America's favorite type of car, well then our population are all of the people in the United States. So the population depends on who you're interested in. A sample is only some of the individuals of interest. So for example, again, let's maybe use favorite ice cream flavor of students at BHS. So the population in that example are the BHS students, so all of them. Okay, a sample might be something like every 5th student on the school list or attendance list or something. Okay, not everyone, just a sample of them. Now, a census is another thing that can come up. A census measures or observes an entire population. Now, we in the United States just got done with the 2020 census. You actually did it by mail if you did it. They do this every 10 years. Every 10 years, they try to update the statistics of the United States population. Now, they get pretty close to everyone, but they never actually do get everyone. That's really, really tough to do. Now, going to page 3. Let me make sure I'm on the right page. Yep, page 3. A couple more words here. A parameter is a numerical measure that describes an aspect of the population. Whereas a statistic is a numerical measure that describes an aspect of the sample. So if you're talking about a few people from a population, that's a statistic. If you're talking about everyone, that's a parameter. A statistic may vary from sample to sample, while a parameter should be fixed or the same for the population. So for example, a statistic would be, so I'm just going to abbreviate, a stat would be rating lunches by asking the first 50 people in line. Okay, so they would give maybe a 1 through 5 rating, and then based on that, you could have a statistic that is describing students' lunch ratings. Whereas a parameter would be something like the proportion of males in the senior class. That's probably something that no matter how we take the data, we could probably get something really close to what it actually is. So that would probably be a parameter. And no matter how many times we try to calculate the parameter, it would be the same. Whereas the statistic, if we ask the first 50 people in line on one day and a different 50 people on another, that might change a lot. So that's the difference between a statistic and a parameter. Still on page 3 down here, I'm going to ask you to try exercise number 1. So I'll read it to you. The television station WHEC wants to know the proportion of TV owners in Rochester who watch the station's new program at least once a week. The station asked a group of 1,000 TV owners in Rochester if they watch the program at least once a week. So there are 1, 2, 3, 4, 5 questions. Why don't you pause the video, take some time to answer these, and then we'll go over this question as a class to see what people wrote. So that being said, I'm going to go on to page 4. So there are, when we take measurements, there are different levels or types of measurements. So you could have levels or types. So the first one I'm going to bring up is one called nominal. Nominal. A nominal level of measurement applies to data that consists of names, labels, or categories. There are no implied criteria by which the data can be ordered from smallest to largest. So, for example, these would be like fair, neutral, poor. So if you've ever taken a survey where those are the choices, that's a nominal level of measurement because it either fits into one of those 3 categories. The next one is ordinal. Ordinal level of measurement applies to data that can be arranged in order. However, differences between the data values either cannot be determined or are meaningless. So for example, class rank. Now hear me out. So let's say that Jim is first, Sue is sixth in line, and then there's Brett, who's the 12th. Okay, now if we're talking the class rank number, then the difference between these does have meaning, but let's talk about their averages. So let's say Jim has like a 102.5, and Sue is a 99.8, and then Brett is a let's say a 99.1. The difference between Brett and Sue in terms of their class rank is only 6, but they're only separated by 0.7 points. Whereas Jim and Sue, the subtraction is, they're 5 away, but Jim, it has a bit more, not too much, but like the difference between the averages has no meaning when compared to the class rank. I hope that makes sense to you. The next one, the next type of level of measurement or type of measurement is interval. So this is similar to what we were talking about with ordinal, but this is where the differences are meaningful. So for example, the year a senator, let's say, was elected can be ranked, and then also the subtractions of those years does have meaning. That one has been there for 15 years, the other has been there 10 years. You can rank them like that. So interval. Continuing on page 4, then we have, I think I made a mistake. I think it's just called ratio. The ratio level of measurement applies to data that can be arranged in order. Both differences between data values and ratios of data values are meaningful. Remember, a ratio is like a fraction. So, if we're talking, as an example, maybe the length of salmon, not only can you figure out the differences between those, but let's say we're comparing, the length of this one particular salmon to another salmon. That ratio would be meaningful if you use that same fish comparing it to another length of a different salmon. All right, so exercise number 2 is asking you what type of measurement are these. So again, if you want to pause and try these out, we can go over that in class when we come back. And that actually brings us to the end of lesson 1.1. So, make sure you get these notes down, answer the questions, and let me know if you have any problems.